To discuss regarding digital communication subject question paper solved problems, that is question answers, important question answers. First question: mention applications of optical fiber. Applications: optical fiber is used in many telecommunications companies to transmit telephone signals, internet communication, and cable television signals. It is also used in multitude of other industries including medical, defense, government or data storage and industrial commercial. Write a note on optical splices. Figure shows above diagram of fusion splicing of optical fiber. It consisting of fiber holder, one side fiber holder, electric arc, and the optical fiber to be connected together, placed one end to other end. Optical splice is a permanent fiber joint whose purpose is to establish optical connection between two individual optical fibers. There are two techniques used for fiber splicing. Mechanical splicing. A mechanical splice has mechanical fixtures and materials that are used to fiber alignment and connection. Fusion splicing. A fusion splice is a fiber joint which is done by heat fuses or by melting the ends of two optical fibers together. Next question, third, explain the types of transmission media. There are two types of transmission media, namely guided and unguided. Guided transmission media are cables like twisted pair cables, coaxial cables, and fiber optic cables. Unguided transmission media are wireless, such as infrared, radio waves, and microwaves. Compare LED and laser diode. Parameters: LED, laser. Working principle: electroluminescence, LED part, laser stimulated emission. Full form of LED, light emitting diode. Full form of laser, light amplification by stimulated emission of radiation. Response: slow response, fast response in comparison to LED. Driving current: it ranges from 50 to 100 milliamps. It ranges from 5 to 40 milliamps. Nature of light: nature of emitted light incoherent and consists of various colors. Coherent and monochromatic. Another comparison: junction area, wide junction area, narrow and small junction. Bandwidth range: it lies in the range of 10 to 50 terahertz. It lies narrow range, that is from 1 megahertz to 2 megahertz. Power to light conversion efficiency approximately 20%, approximately 70%. Numerical aperture of obtained light beam: higher in LEDs, extremely low as compared to LEDs. Cost: low cost and thus economical, high cost and thus used in specific application. Fifth question, define numerical aperture and angle of acceptance. Numerical aperture is the ability of an optical fiber to confine the incident light ray inside it. As the acceptance angle is the maximum angle through which light enters the fiber. Next question, explain with a neat block diagram optical fiber communication system. It consists of drive circuit, light source, optical splice, optical couple or beam splitter, optical receiver, electronics, optical transmitter, optical amplifier, photo detector, receiver, amplifier, signal restorer. Now let us study one by one. Transmitter. An electrical signal is applied to the optical transmitter. The optical transmitter consisting of driver circuit, light source and fiber fly lead. Driver circuit drives the light source. Light source converts electrical signal to optical signal. Fiber fly lead is used to connect optical signal to the optical fiber. Transmission channel. It consisting of cable that provides mechanical and environmental protection to the optical fibers contained inside. Each optical fiber acts as an individual channel. Optical splice is used to permanently join two individual optical fibers. Optical connectors is for temporary and non-fixed joints between two individual optical fibers. Optical coupler or splitter provides signal to other devices. Repeater converts optical signal into electrical signal using optical receiver and passes it to electronic circuit where it is reshaped and amplified as it gets attenuated and distorted with increasing distance because of scattering, absorption and dispersion in waveguides, and this signal is then again converted into optical signal by the optical transmitter. Receiver. Optical signal is applied to the optical receiver. It consisting of photodetector, amplifier and signal restorer. Photodetector converts the optical signal to electrical signal. Signal restores amplifiers are used to improve signal to noise ratio of the signal, as there are chances of noise to be introduced in the signal due to the use of photodetectors. For a short distance communication, only main elements are required: source, LED, fiber, multimode step index fiber, detector, pin detector. For long distance communication, along with main elements, there is need of for couplers, beam splitters, repeaters and optical amplifiers. Source: laser diode, fiber single mode fiber, detector avalanche, EPD. Write a note on WDM. Wavelength division multiplexing is a technology or technique modulating numerous data streams, that is optical carrier signals of varying wavelengths of laser light onto a single optical fiber. WDM enables bidirectional communication as well as multiplication of signal capacity. WDM is actually frequency division multiplexing, but referencing the wavelength of light opposed to the frequency of light. However, since wavelength and frequency have an inverse relationship, the WDM and FDM terms are actually describe the same technology, light in optical cable used to carry data and communication signals. Explain the block diagram of pulse code modulation, a technique by which analog signal gets converted into digital form in order to have signal transmission through a digital network is known as pulse code modulation. It is abbreviated as PCM. PCM systems are basically signal coders, also known as waveform coders. PCM allows the representation of the continuous time message signal as a sequence of binary coded pulse. The binary form permits only two probable states, that is 0 and 1. The major steps involved in PCM is sampling, quantizing, encoding. Basics of PCM. Pulse code modulation. The analog message signal is first sampled and then the amplitude of the sample is approximated to the nearest set of quantization level. This allows the representation of time and amplitude in a discrete manner, thereby generating discrete signal. This discrete signal is then converted into its binary form for the transmission of the signal. It is to be noted here that the PCM technique, the signal gets transmitted in the coded format and must be decoded at the receiver in order to have the original message signal. Below figure shows block diagram of pulse code modulation. Analog message signal, which is the input given to low pass filter, sampler, next given to quantizer, encoder. PCM signal output is taken to the regenerative repeater. Where it is distorted signal, again it can be reconstructed. Regenerative repeater, regenerated PCM signal, again it will be given to regenerator, decoder, low pass filter, receiving end. It is basically composed of a transmitter, a transmission path, and a receiver. The transmitter performs sampling, quantizing, and encoding of the signal. The transmission path includes regenerative receivers that recover the signal from the undesired noise effects. Next question, ninth one. Explain generation of PPM signals. Generation of PPM signal. The PPM signal can be generated from PWM signal. The PWM pulse is obtained at the comparator output are applied to the monostable multivibrator, hence corresponding to each trailing edge of PWM signal, the monostable output goes high, it remains high for a fixed time decided by its own RC comparator. Thus, as the trailing edges of PWM signal keep shifting in proportion with the modulating signal x of t, the PWM pulses also keep shifting. All the PPM pulses have the same with the and amplitude. The information is conveyed via changing the portion of pulses. Below figure shows the pulse position modulation PPM. First what? Comparator. The signal will be given sawtooth signal PWM. Output is monostable given to monostable multivibrator. Output is PPM signal. Generation of PPM signal. Message signal, carrier wave, modulator. Output is a PAM signal given to comparator. Then sawtooth generator, which will be given to the negative terminal of the comparator. Output is PWM signal. Generation of PWM signal. Figure shows the process of pulse width modulation. It is commonly known as indirect method of PWM generation. Pulse width modulation. A modulation technique where the width of the pulses of the pulsed carrier wave is changed according to the modulating signal is known as pulse width modulation. It is also known as pulse duration modulation. Basics of pulse width modulation. It is a type of pulse time modulation, the technique where the timing of the carrier pulse is varying according to the modulating signal. In pulse duration modulation, the amplitude of the pulse is kept constant and only variation width is noticed as the information component is present in the width of the pulses. Thus, during signal transmission, the signal undergoes pulse width modulation. Due to constant amplitude property, it gets less affected by noise. However, during transmission channel, noise introduces some variation in amplitude as its additive nature, but that is totally easy removable at the receiver by making use of limiter circuit. As width of the pulses contains information, thus the noise factor does not cause much signal distortion. Hence, the immunity to the noise of a PWM system is better than PAM system. Generation of PWM signal waveform representation. The above figure shows generation of PWM. The message signal and the carrier waveform is fed to the modulator which generates PAM signal. This pulse amplitude modulated signal is fed to the non-inverting terminal to the comparator. Ramp signal is generated by sawtooth generator is fed to the inverting terminal of the comparator. These two signals are added and compared with reference voltage of the comparator circuit. The level of the comparator is so adjusted to have the intersection of the reference with the slope of the waveform. The PWM begins with the leading edge of the ramp signal and width of the pulses is determined by the comparator circuit. The width of the PWM signal is proportional to the omitted portion of the ramp signal by comparator level. These all question paper problem solved 5 marks and 10 marks. Depending upon the marks you have to write in the exam. For 5 marks question you have to write definitions, if it is necessary draw the diagrams. For essay types questions 10 marks will be there, you draw diagrams, label it properly, and I have solved previous question papers, digital assignment 1, digital assignment 2, and in my previous slides I have slides will be there as according to the question bank which will be given. For any difficulties contact me. Thank you.